Howdy, folks. Welcome to episode 5 of the Jump the Shark podcast. I'm Matt Jarvis, and I'm missing my regular co-host, Gerred Dillon, today. I'm not entirely sure where he is. Maybe he's asleep, and we've got the time zones wrong. But I'm happy to be joined by today's special guest, Adrian Moats, Chief Scientist at Container Solutions. Welcome to the show, Adrian.
Hi there. Thanks for inviting me.
That's all right. You may regret that as the show goes on, but we'll see. As always, if folks are watching on the live stream, if you have any comments, questions, whatever, stick them into YouTube, and we'll pick them up here. So, Adrian, where do we start? Lockdown. How's lockdown working for you?
Not too bad. I do need my hair needs seriously cut, but
yeah, I'm sporting my new lockdown haircut today.
Fair enough. Yeah. I've seen some. I won't mention who, but an employee at Container Solutions posted their haircut. It was with clippers, and I had question marks over their abilities there.
So, are you based from home normally, or
quite a lot? So I'm based in Edinburgh, and there's actually a place called Codebase, which is like
I know it well.
It's a co-working place, but a lot
the home of the Kubernetes Edinburgh meetup.
That's right, of course.
Which is the best place in Edinburgh for any cloud native meetups.
Yeah, so like Codebase runs a lot of community events around tech, and so it was a great place to have a desk. I just had a desk in the co-working.
Oh, right, cool.
I would use regularly, but yeah. Since all this happened, I've not been there, so it's a bit sad.
Yeah, so I mean, you and I have done quite a few of these. Done a couple of these virtual things together over the last few weeks, haven't we? Luckily, this one's not in fancy dress.
True.
Makes it slightly easier. How have you found giving talks and stuff in the virtual space? So we were talking about lighting just before the show started, weren't we?
Yeah, so I mean, I was kind of saying I need to get a new webcam, or what's the word? A webcam that's not part of the laptop.
Yeah.
And but they're all sold out, or all the good ones are sold out, and I don't want to just plump for whatever's available. Yeah,
that's true. You can't get webcams for love nor money at the minute. Mm-hmm. I don't know what's happened to them. I guess.
Well, just a huge spike in demand, I guess.
Yeah, absolutely. Although, but that could be working in your favor. The haircut bit, you can't see you very well.
True. I'm not sure what you're trying to say there. But...
so let's keep things moving along here. Why don't we'll start with our regular section, Cloud Native News, and I get to cue this.
How much time?
So, what have you seen in the world of cloud native news in the last couple of weeks that's been interesting to you?
That's a good question. Let me refer to my notes.
This is supposed to be off the cuff, Adrian.
No, actually, there's quite a few things. It covers 2 weeks, so I have to think back a little.
Yeah.
One thing that Container Solutions has been blogging about, and I thought was really quite interesting myself. I didn't have time to play with it yet, but it's Tinkerbell.
That's super interesting. Let's see if we can. Let's get the Tinkerbell up on the screen. We want. I've lost it now. There we go. So Tinkerbell, yeah.
Yeah, so I'm not really the right person to take you through it. I've got a feeling you might actually know more than me, but basically, one of the people at Container Solutions had a blog on it, or blog series on it. It was 3 blogs, so it was quite a lot of work. But they did a home office cluster from Raspberry Pis, but they provisioned it all using Tinkerbell. So basically, if you were to add a new Raspberry Pi to the cluster, what would happen is it would get like pixie booted and given an image automatically, and it'd be up and running and part of the cluster, completely automatically. So I assume Tinkerbell is. I'm not quite clear, like if it's the same stuff that's used at Packet, or if it's just related to.
So just for folks who may not know the background to Tinkerbell, so Packet, when Packet originally started, their head of engineering at the time wrote a pretty well-known blog post. They were planning to build Packet around with OpenStack as the underlying platform. And the OpenStack bare metal provision, ironic at the time, was pretty basic, and so they got a certain path down that road, realized none of it worked, and then decided they were going to write their own, and they just open sourced this, I guess 3-4 weeks ago, which is pretty cool.
They should have called it ironic. Bare metal.
Sorry.
They should have called it ironic. You said it was ironic. They should have called it ironic.
So, I mean, in actual fact, the ironic stuff from OpenStack got a lot better over the years.
It is called ironic. Sorry.
Yeah, no, it is called ironic. Yeah, so it's the actual component that does bare metal provisioning. It's the same code that's used. I don't know whether you've seen. It's metal cubed, isn't it? The Kubernetes bare metal provisioner. I don't know whether you've come across that. So that's the OpenStack code, kind of slightly rewritten to allow it to run standalone, to not require any of the other components. But we're going to have, I think Mark Coleman from Packet is going to join us on the show in a couple of weeks. So I will be quizzing him about Tinkerbell and all things bare metal provisioning.
It is interesting how they mention Kubernetes right there in like the first page. I guess it doesn't necessarily have anything to do with Kubernetes.
No, I mean have you used Packet much as a platform?
No, I've not.
No, me neither. I think you can do pretty cool stuff with it, though. I think the networking layer is pretty cool, like how you can hook things up together, but bare metal provisioning is a hard problem. Having run a public cloud, it's still a really tough. You would think we might have solved some of these problems over the years, but hardware standardization and standards compliance in hardware leaves something to be desired usually.
Yeah.
What else did you have that was interesting this week?
So this is a slightly old article, but I did have a link to Microsoft's article on Rust. I'm not quite sure, but maybe come back and talk about Rust more later. But Microsoft, and also links into stuff I think you want to mention later as well. But obviously, there's constantly like CVEs related to Windows and I guess Office and everything, and so many of them are caused by memory errors.
Yeah,
mistakes made by programmers and handling errors because it's written in C++. And so Microsoft are really trying to push a move towards Rust to try and reduce the level of those errors. And yeah, from personal experience, and maybe we'll talk about this again later, but from using Rust, I really think that's probably quite likely to work.
Yeah, it's interesting, isn't it? There's still a lot of stuff written in things like C++ and C. I've programmed a little bit in C many, many years ago, but it does require you to understand a lot deeper level than most new languages do in terms of what's actually happening in the memory.
To be fair, I would say Rust does still require you to have a reasonable understanding to use it properly. But if you get it wrong, it doesn't crash in the same way that C does. But yeah, just looking at the article, like they say, 7% of CVEs originating in Microsoft are memory safety issues. And
yeah, that's a lot, isn't it?
Staying steady, right? It's not like it's going down over time. It's staying there, which is scary. So even as people have been trained better and presumably know better, we're still not reducing this incident rate, which is surprising.
Yeah, why do you think that is?
It does surprise me slightly. Like you would think. I know, for example, how long ago was I doing that? So in 2005, I was working at a company doing C++, and back then we had an old version of Microsoft C++, and even then it would tell you if there'd been memory leaks after you ran and things. So even then it had some support for making sure, or helping you make sure there wasn't like memory problems. And then you got stuff like Valgrind, which was pretty good. And you can run that, and that really helps you try and figure out if there's memory issues. So I am surprised it hasn't come down more. I think it's just like C and C++ are fundamentally difficult. It's just difficult to get it right. It's a burden that shouldn't be entirely placed on the programmer, I guess. But it does surprise me it's still that high. I guess it's just legacy code. You're always constantly interfacing this legacy code. And you probably, there's destructor methods you're expected to call. And if somebody hasn't read documentation, which is basically all of us, you don't realize that at first. And you just don't call the destructors properly, I guess. But that's
I mean, I guess Windows must be a pretty huge beast, I suspect. In there's got to be a pretty big code base with a lot, as you say, plenty of legacy stuff in there to the stuff that's probably been sat in there for multiple versions of Windows.
Yeah, and he looked further in an article. It says in 2004, each error cost industry, I don't know if that's Microsoft or industry at large, $250,000 each. Wow. And Microsoft estimated that's on the low end. So you can see like the reasons they want to move, because that's enormous amounts of money you're potentially saving for anything that's would be considered legacy code like Windows.
Yeah, well, I mean, I guess you only have to look at how things like Windows, they're still very much managed in that old enterprise way. If you're a massive enterprise and you need to roll out a patch to Windows, I mean, that's a nightmare scenario, isn't it, for all of us who've been administrators in our time. People don't like to have to fix problems across their entire fleet of machines, and managing Windows isn't like managing containers, is it?
Yeah, and I mean the thing is, Windows has to support so many stuff back, like going back in time, like old ancient devices and so on, that you can understand why there's a lot of crufty code in there.
Yeah, absolutely. Well, perhaps we'll come back to this topic a little bit later on. What I seen this week that was interesting. So let's take this out and stop that. So I read a blog post from Coinbase that was super interesting. This is I don't know whether you're familiar with Coinbase, big blockchain company, and their director of engineering wrote this blog post about why they don't use Kubernetes, and it's a really well written blog post, and the rationale is pretty clear for them. It's definitely a conversation I've had with a lot of people over the last few years, around the container space. Is why people shouldn't necessarily immediately think that running Kubernetes is a good idea, right? Because unless there's loads of situations in which you don't require complex container orchestration.
Yeah, and so, sometimes I'd agree with you, especially like when things are on the small end. But Coinbase is a large company, and I think they're actually making a big mistake here. I really do.
Really? Interesting.
Because what they're going to do, I mean, I remember like when Kubernetes, wasn't clearly, there's multiple choices like Mesos with Marathon, and there was, Nomad was barely a thing then, and there was Swarm, but even before then, like Spotify, for example, had their own thing, and there was something called Fleet that was basically system managing containers. So there's a bunch of options, and there's a reason that companies moved away from those. Or rather moved away, like what I'm trying to say is a lot of companies created their own solutions. And there's a reason they stopped doing that. And it's because they just ended up spending all the time supporting those platforms and building out those platforms.
Yeah, true.
So what Coinbase is going to end up doing is like adding in code to fix issues that they find, and they're going to end up recreating Kubernetes.
Well, so the two rationales that they give in this blog for not using it is that their deployment pipeline is super simple, and they don't need all the bells and whistles that Kubernetes now gives you. And I mean, you can kind of in some ways see what I mean. You see this a lot in platforms generally, don't you? That when they become super successful, they have to cater for all use cases, and so that it becomes much more complex. I mean, if you go back to the start of something like Kubernetes, the idea was super simple app deployment, right? It's kind of like Heroku. You just throw stuff at it and things happen. And now Kubernetes has become, you've got to understand about infrastructure because there's storage, there's networking, there's all this other things in there that you as an app developer don't necessarily care very deeply about. So I guess it depends how complex their pipeline is. I mean, they say in this article that if they did switch to Kubernetes, they'd actually need a much bigger team to support it.
Yeah, I don't. Well, I guess they must be running on-prem, right? I can't remember it even says that in the article.
Yeah,
you're not running on-prem. Like I would say, move to JKE or something, and then you're definitely going to save time. But
I suspect they are on-prem, given what their core business is.
Oh, yeah, that's a fair point. Yeah.
They're now managing, was it $6 or $8 billion of?
Yeah, right. Yeah, they probably got cold storage. That might be the main reason.
Yeah, I don't think you want to be putting that on AWS, right?
Maybe not. Yeah, so that could actually be a prime motivation, but I'm still very skeptical because it must be a large platform. I mean, they're a large company with lots of users, and they're going to start hitting problems with scaling. They're going to start hitting problems with deployments and rollbacks. And these are things that have been solved in Kubernetes, and they could just be using that. And I think it would save them time. And I think, honestly, they're going to revisit this. I'm not saying they'll solve it with Kubernetes. There probably will be something better or new or more appropriate for them by then. But I think rolling your own platform just based on top of containers is probably a mistake.
I mean, even just at, I guess, even when you look at the complexities of scheduling, right?
Exactly.
Like the problems that get solved in efficient schedulers that have had lots and lots of tire kicking over the years. They're pretty hard problems in computer science, really, aren't they? Yeah. Like scheduling things. So. I mean, security was the other thing that this blog talks about, is that, they want to reduce the attack vector because, the way they see systems like Kubernetes now, or it's not just Kubernetes, is it really? Because, and we've talked on this show before about this, that, when you look at the entirety of what you're likely to be deploying, if you're deploying Kubernetes at scale these days, Kubernetes is actually only one piece of it. Your service mesh, whatever you're doing for authentication, authorization, secrets management, all of these things that all then have their own attack vector and their own possibility for bugs and all the rest of it.
Yeah, and that's also a very fair point, but and I think it does reduce attack vector, but it reduces attack vector like in the same sense that security through obscurity does. If you see what I mean, they're maybe less likely to get attacked because they're not running Kubernetes, and so all there's a bunch of generic attacks and known CVEs that can be applied to Kubernetes, but like an attacker would have to specifically come up with an attack against Coinbase.
Yeah, it's interesting, isn't it? Whether you've got that, what are the trade-offs there? Is it true that what's the old quote about eyeballs, from Linux, that the more eyeballs you've got, the less
all bugs are shallow given enough eyeballs.
Yeah.
Eric Raymond, who isn't my favorite person, but yeah.
Yeah, so I might hold some other questionable views, but got it right with some of the software development stuff. Okay, what else was I looking at this week? This is a shameless plug for Data IQ, I'm afraid, but it is an interesting podcast. Let's just get hold of this one.
Yeah, I had a quite look at it. No, it's an interesting. I only read the notes. I didn't listen to it, but it's interesting. And I agree with it.
Our one of the founders of Mesosphere and obviously Data IQ, Ben Heineman, who's also one of the co-creators of Apache Mesos. So Mesos came out of a research project at University of California, Berkeley, and Ben was one of the people who worked on that. And this podcast, Ben talks a bit about sort of the history of containers, how Mesos and Kubernetes kind of relate to each other, and then also about how the benefits of sometimes taking lessons learned from previous technologies and applying them to newer ones. So with the example being things like Kudo, which is the operator project that we spun out, that has its roots in a way in Mesos frameworks, from a architectural perspective.
Yeah, I also think like the points, very valid about Mesos helping Kubernetes grow. If you look at, was it the Omega paper? I can't remember what they're called.
Yeah.
But they explicitly mention Mesos because they looked at all different ways of doing things with like Borg and Omega and so on. And they built the sort of scheduling that ended up being used in Kubernetes, by looking at what was existing and what were the problems and what were the best approaches. And Mesos is interesting from like its frameworks approach and so on. It's got a slightly different approach to most other orchestrators.
Yeah, I mean, I think, I spent when I joined Mesosphere, I spent a lot of time at conferences talking about Mesos and how Mesos actually works, and you had a lot of people who were fairly new to the container space who would kind of make this comparison between Mesos and Kubernetes. And, it's the wrong comparison, really, because Mesos is actually lower down the stack than Kubernetes is,
right.
And
it's like Kubernetes is something like a Mesos framework in a way. Yeah,
exactly. Yeah, because in the Mesos world, you'd have had something like Marathon, which is really the equivalent of Kubernetes, because in Mesos the scheduler doesn't care about workloads, which is one of the reasons why it's massively scalable, and why Twitter and Uber and all those folks adopted Mesos as the way to manage really large scale container stacks. I mean, it's not really clear yet. I don't know how big the biggest Kubernetes clusters are. Do you know what?
I mean, to be honest, you tend to start going towards multiple Kubernetes clusters.
Well, yeah, exactly. That pattern in that's that kube sprawl thing, isn't it? Or in the Kubernetes world, that people start to have cluster proliferation and end up with crazy things like a Kubernetes cluster per developer. And
yeah. So I mean, that's actually something we discuss a lot at Container Solutions, and I think most of our consultants are towards fewer clusters, but generally more than one, which is quite interesting.
Yeah,
people go for many clusters. I mean, and one issue is that we never had proper, what's the word? Not silos, but namespacing again, not namespacing.
Yeah.
But, you never really had support for having different teams or different.
Yeah, so
that was always added later.
Yeah. I mean, it's an interesting. I mean, I've talked to conferences about this. This idea. I think when you look at orchestration systems as a general, in the abstract, we all started from this position of a single cluster that abstracts away all of your underlying infrastructure. Was the dream, and we've kind of ended up in a bit of a different space, really, for a variety of reasons. I mean,
I mean, I would like to see it evolve again, because I think for most companies they probably want something closer to a PaaS, and I've never really been quite sure why PaaS hasn't been more popular. I suspect it's largely to do with lock-in, but I'm not sure about that.
Yeah, I mean, it's and again, this is something I know a lot of people in the industry are talking about now. I mean, as we started around with the Coinbase discussion, that Kubernetes in a way is not the solution to all problems, because you have to know about so much stuff. It's not the app deployment panacea because in a way it's moved far wider than being about app deployment. It's now about building infrastructure platforms. But
yeah, I used to like teach Kubernetes training courses, and yeah, there was a lot in there. There's a lot of basic stuff you need to understand before. It's not basic. It's a lot of concepts you need to understand before you can really effectively use Kubernetes and not get confused.
Yeah, absolutely. I mean, I think it's easy for folks like us who fairly long in the tooth around this space to make assumptions that the things are obvious when they're really not. But maybe we need something like Heroku again. Where you just throw some code at it and.
Well, I think we will get that. I think you'll start seeing more sort of PaaS based on top of things like Kubernetes, but there's also movements like K3S, which is quite interesting, which is like a really sort of cut down Kubernetes.
Yeah, I mean, I know a bunch of folks at Rancher that seems to be getting a lot of uptake, particularly, I mean, that's all obviously aimed at that edge and IoT kind of space, right? Where it becomes even more one cluster per application almost.
Yeah, maybe. I think it's of general interest, to be honest, but yeah, certainly that's one of the prime targets. Yeah.
Right. What else did we have for today's news? Let me just stop sharing that one. Get my notes up. Oh, so we should talk about the new top supercomputer. That was kind of interesting, right? I know it's not directly connected to cloud native, but it's super interesting because it's ARM based, which is the first time an ARM supercomputer has ever topped the top 500.
It must be enormous.
Yeah, this Fugaku supercomputer. So I mean, so I think we've both got a bit of a past in HPC, right?
Yeah. So when I was back at uni, like doing my undergrad, I did a couple of internships at Sun Micro, which was quite interesting. So at that time, it was right around the time of the .com boom. First time I was there was a year before, and they were selling so much equipment. And I was like, so they had a big factory in Linlithgow. I mean, I think it's still, I think Oracle owns it now. And they were shipping so much stuff in that year, which would have been like 99. And then I went back for a second internship the year after, just in the summer between university years. And that's when the .com boom hit, and it hit him. So different. But yeah, it was interesting because they, back then, if you wanted to run a software company, you bought like a Sun server effectively. And those servers were effectively HPC or Big Iron or whatever you want to call it. And kind of close to this. And then once I did a MSc in high performance computing at what was then called the Edinburgh Parallel Computing Centre, and is now just known as EPCC. And they still host the UK supercomputer, actually. Right,
awesome. Yeah, I mean, I did quite a lot of stuff around OpenStack for HPC and high throughput computing as well. So it's a super interesting space. And when I was at IBM, we had a lot of contacts with the UK supercomputing kind of industry. It's Daresbury Labs and stuff like that. But
yeah, exactly.
One of the big problems here is about exascale. So this is where the ARM thing becomes super interesting, because with standard architectures for supercomputers that jump to exascale, which is like the next it's the next non-incremental kind of big jump in computing power. You know, you would need to. I remember there were folks inside IBM who were modeling this, so how much power and cooling you would need to, you know, with a standard architecture to build an exascale supercomputer. And it was like more power than the sun has outputted in, you know, the last 20,000 years or something. It's just physically impossible. So in that world, I think a lot of stuff is, you know, really focused on how can you do more for less power, because power is actually your limiting factor.
Yeah, it is something we try to get a lot better at, I believe. I think like people generally, you know, if you have an old supercomputer, you generally you can't run it because of the power cost, is my understanding.
Yeah.
It's so much cheaper to buy a newer one because of the power cost rather than anything else.
Yeah, I mean, they do replace these stuff on a fairly regular basis, don't they? I mean, nobody sits at the top of the top 500 for like longer than a year or something, and at that point, you're looking at building the next one.
Yeah.
And they cost unbelievable money. So,
I mean, when I was at EPCC, when I was working there, so I did my MSc, then I went traveling, then I worked somewhere else, but then I went back to EPCC, and I worked there for a long time. Like, it must have been 10 years or so.
Right.
And I generally was like doing applications, so I wasn't generally on the high performance computing side, but I did do support for. It's like first line support for the UK national supercomputer, which is quite funny. It was like Hector. I think it was called Hector then, and then it became Archer. And I couldn't tell you what it is now.
What architecture was that? Were those things based around?
I can't even remember. I suspect it was IBM. I think.
Yeah. Well, IBM were right up there for a long time in terms of their processor architecture stuff.
Yeah, there's all the Blue Gene stuff and things like that. I can't remember.
Yeah. No, I do like I like big racks full of flashing lights as well. I have definitely have a soft spot for anything with lots of flashing LEDs.
Cool.
All right, let's take that out. So, let's talk a bit about you and what you do. So, what I'd like to start with, kind of how did you get into this world of cloud native?
Yeah. Well, I mean, to be fair, it actually leads quite nicely on, because after I left EPCC, I was doing contracting work, but I did some work with a company in Amsterdam, and around that time, I was with Jamie Dobson, who became CEO of Container Solutions, and Penny Resnick, who's the CRO, and also Mark Coleman, who said will be on the show in the future. And so I was working with all three of them, and Docker came out. I think it came out a little bit before, and Penny had seen it, and he introduced it to us, and it started to take off, and we started running the Docker Amsterdam meetup. And that's where it all started. And then we got the idea for Container Solutions. I didn't join Container Solutions at the start. I went and wrote a book called Using Docker. I moved back to Edinburgh, and
nice plug.
Well, to be fair, I wouldn't buy Using Docker at the minute, because it's too out of date, I'm afraid. But maybe I'll do an update. We'll see. But so I wrote the book, and one thing that happened was the first DockerCon EU, which I think would have been 2014, was in Amsterdam. And the reason it was in Amsterdam is because we tried to organize DockerCon, like a DockerCon, because there's DockerCon US had been announced, but nothing in Europe. And so James says, "Oh, we'll do it." But then Docker got in touch and said, "No, we'll do a proper one." But we ended up still sort of helping to organize DockerCon EU. So that's why it was in the Science Museum Nemo in Amsterdam.
So how big was the first DockerCon EU?
It's still reasonably large. I couldn't tell you exactly. It must have been. I mean, it's still thousands.
Right.
Oh, maybe not. Maybe it was certainly large. It was certainly hundreds anyway. And I don't know if you remember Rocket. They announced Rocket. CoreOS announced Rocket during DockerCon EU, just to annoy Docker, I guess. That was quite amusing.
Is Rocket still a thing?
No. Oh, I did listen to your podcast of 2 weeks ago, because you're talking about Flat Car Linux, and I think Cheryl I mentioned Rocket in that context. And she's absolutely right that Flatcar Linux is a continuation of CoreOS. I can't remember what it's called at CoreOS, but it's not the continuation of Rocket. Rocket's really gone. But the CoreOS, I can't remember what they call it. They had like this whole platform for updating the OS and so on, which is really quite impressive. Like it just gives you a whole platform to like keep your everything up to date when you're running Kubernetes. And so that's what Flatcar Linux is. It's basically an OS for running Kubernetes.
Yeah, I was talking to one of the folks at Kinvolk today about Flatcar.
No, I really like the guys at and everyone at Kinvolk. It's quite an impressive company.
Very cool. So your job title, Chief Scientist. That's great. What does a chief scientist actually do?
Well, that's a good question. So I guess it came about mainly because I met look more into research and products around containers and cloud native, as we call it now. So Container Solutions is primarily a consulting company. So I'm kind of on the periphery, I guess, and I'm tasked with doing more sort of product-based stuff, more open source-based stuff, and trying to see where things are going, I guess. And as part of that, I think we'll come back to this later, but I've been doing a lot of work into container registries at the minute. Yeah,
we're definitely going to talk about container registries. I mean, I think it's obviously the container space has changed a fair bit since you folks first encountered Docker back in Amsterdam, right? I mean, I think Container Solutions is just an interesting company because you come at this stuff from all sorts of different angles, right? From the technical and the kind of human angle, which is quite unlike a lot of other consulting companies.
Yeah, and I mean, I have to credit Jamie there. He was always taking a holistic approach, and Penny, like we've all. I mean, if you've ever worked for a consulting company, I mean, every project I guess anybody's worked on, you quite quickly realize in your career the problem isn't the tech; it's getting people to work together, right?
Always the people.
Yeah. And for that reason, I guess, and other reasons, like Jamie in particular is interested in, making things better, I guess, in the industry and the world. So for that reason, he spends a lot of time talking about ethics and looking into ethics. And Anne Curry, who works with us sometimes, she's also very into ethics and ran like a track and a conference all about ethics. And has been leading one of the leaders in the push towards getting people to look at what clouds they're using and trying to make sure whatever region they use or whichever cloud provider they use supports sort of renewable or green energy. And trying to push people to like be honest and open about how much of their energy for the data centers comes from green energy and where they intend to move to, which is a really good idea, I think.
Yeah, and I mean, I think the kind of having been involved in consulting projects myself as well, that thing about people is really true. That's always the biggest problem with especially with big change, isn't it? So it's surprising more people don't come at it from a kind of psychology perspective to start with, because really, you can only be successful in big digital change if you can, create that change in people, and that's the much harder bit than than just making changes in software.
Yeah, so I'm loath to do this, but I probably should plug Jamie and Penny's and book called Cloud Native Transformation, and they do actually it's mainly Penny, but they do talk about exactly this and what you need to do to be successful at a cloud native transformation. And by that they mean updating your IT or whatever to a more modern system. It's not something that you can just say you're going to do it and do it. So, I mean, some people do try to do exactly that, and we call it lift and shift. And that can be successful in some circumstances, but generally in very isolated cases where you're sort of doing it intentionally. In most cases, what you'll find is people try and do a lift and shift. And what will happen is, okay, everything's running in the cloud, but you've no idea how to take advantage of all the cloud stuff, if you like.
There's a penny in Jamie's book.
Yeah. And I should have mentioned Michelle, actually. She did a lot of work as well.
Yeah, I mean, I absolutely agree with you. You know, I mean, it's because the other thing you see as well in you know, particularly inside bigger organizations, is how often transformation projects actually fail. You know, and they tend not to really fail because, you know, necessarily about the technology. They failed because you didn't think through what the implications were of the technology, you know, what the process change needed to be, how you could change people's mindsets, how you could get people to
exactly, and like training, getting people on site. Yeah, exactly. It's and you've got to remember, people are naturally going to be scared, because if you're changing the whole systems, then people are wondering, well, where's my job going to be?
Well, yeah, exactly. I mean, I've seen that all the way through my career. You know, I mean, there's lots of jobs in IT where people have just done the same thing all their lives. You know, they've managed one application for the last 20 years, and you know, that's a whole career in itself, just managing that one application. And the cloud native world comes along, you know, and you know, from a development engineering perspective in our world, you know, most folks tend to be, you know, fairly young, right? And you know, but when you look inside big enterprises, that's you know, you've got a whole range of folks inside organizations like that who are doing things that maybe, you know, Kubernetes means nothing to them.
Yeah. And I don't think startups realize that, by and large. And a lot of the industry, like the Hacker News, doesn't realize that, by and large.
No. I mean, you know, I've been an IBMer, so I've seen all of these these like legacy kind of, you know, legacy businesses that have got completely different IT stuff. So let's talk about container registries, because I know that's something you're super interested in at the minute. So you've written most of, this is where we get into the other big problem in computer science, is naming and pronunciation.
Okay.
How are we pronouncing this? Is it trow? Is it tro?
It's trow. Yeah, maybe I didn't give it the world's best name. Do you know where it comes from? You maybe looked it up.
No, I don't.
Okay, so I called it, originally it was called Lycaon or something, and then I decided that was a bad name because it's about a king that ate his baby, basically. And there was a reason for it. Basically, before Trow and before Lycaon, there was something called Image Wolf, which is my attempt. Oh, it wasn't an attempt. I basically, it's I think the repo still exists, and Image Wolf basically does like BitTorrent connects like a Docker distribution registry. So nodes on a Kubernetes cluster. I connected nodes on a Kubernetes cluster using BitTorrent, so you could download images faster. And like that actually worked surprisingly easily.
I remember did you blog about that at some point? I remember reading about that, I think.
Probably a long time ago. But yeah, it was just a proof of concept. And I decided to like try and build Trow. And to be honest, I haven't got to the same stage with Trow. So it doesn't do the BitTorrent bit yet, but that's definitely on the roadmap, and hopefully we'll get there soon. But yeah, Trow is called Trow. And the reason it's called Trow is, no, it's not really a good reason. It's but Trow is a Shetland fairy, if you like. So I'm from Shetland, which is an island to the far north of Scotland. In our folklore, we have these things called trows. I guess it's also kind of similar to the Scandinavian troll. I'm never quite sure. And for whatever reason, I decided to name it after that because I thought it was quite a nice name. And I hadn't really realized at the time the confusion between tro and trow, I guess.
Internationalization problems.
Yeah. I mean, I don't mind if people call it tro, but yeah.
Why did we need another registry and image manager? Why is this space interesting at the minute?
Yeah, so that's a very good question. And really, in my opinion, it hasn't moved much in the past, since 2014. I guess like when Docker was first out, they had the Python version of the the registry, and really it hasn't changed much at all since then. And I think we can do a lot better if we start adding a few more features and integrations into our registries, and we can do better about things like auditing. We can definitely do better with things like distribution, which is going back to the image wheel thing. If you consider that, if you push out a new version of an image, and that image is maybe like part of a, I'm trying to remember not a stateful set, a daemon set in Kubernetes, which means it'll run on one instance on every single node. Then each of those nodes has to pull the image. And if you're on a large cluster, there can easily be hundreds of nodes.
Yeah.
And each of those are going to have to try and pull the image. Interestingly, they won't pull the image at the same time because you've probably got like a roll in deployment. So it'll pull like one by one by one by one.
Yeah,
by one. And every node won't start pulling until the last one has finished. But we could speed things up enormously if we just like pull every image at the same time. And you can do that, and you can sort of push it onto the node before the node needs it. And that has the potential to like speed up deployments quite a large amount. And if you can speed up deployments quite a lot, then you're saving your team time, and everything becomes a bit more agile and faster.
Yeah, I mean, those kind of things that matter a lot more at scale as well. I mean, that was one of the big performance bottlenecks in large OpenStack clusters was moving images around. And so I think the pre-caching and stuff like that ended up solving that problem in OpenStack. But yeah, I mean, it was gigantic time lapses when you needed to spin up huge amounts of VMs at the same time. And it's no different from the container space in that sense, right?
Yeah, well, I mean, you'll have lots more containers. The image size might be smaller, but there's lots more of them. So
yeah.
I should say there are there's stuff like Kraken, which is from Uber, that does kind of exactly this, but it's you might have problems integrating into your system because it was designed for Uber, but they basically use a P2P strategy for.
Yeah, I've seen that. That's a super interesting project. So that's kind of the same as your thing with BitTorrent, right? That it's
So, but it's very much just that bit. So, like, if you were to try and use it, you have to make changes to your workflow. And I sort of feel like we could do something that's a lot easier to use, and also applicable to people at the smaller scale. So, I think we can still improve speeds and not require significant changes to your workflow or anything. And there's also Dragonfly, which is now a CNCF project.
Yeah, I've seen that one as well. I think there's quite a lot of activity happening in this space at the minute, isn't there? There's quite a lot of people thinking about this because we've kind of we're not just dealing with images anymore, are we? We're actually creating a lot of artifacts generally,
right?
Of the stuff that doesn't necessarily fit tightly into this I'm a container image.
And I think this literally seems to have started changing this year. And if you look at stuff like the GitHub package repository, like that supports a whole bunch of different stuff. It doesn't just support Docker container images, but jars and so on. And if you look at Google, they've got there was what's called Google Container Registry, GCR. They've now changed it to be Artifact Registry. Is that correct? It's something like that.
Yeah, I don't know.
But they're now saying okay, we're not going to store just Docker images. It'll store npms and jars and so on. And then there's stuff like Helm files and so on. And a lot of this, or part of the push for all this, came out of the ORAS project. So there's a standardization for registries called the OCI distribution specification. And there's also something called OCI registries as storage. And that's like a Deus Labs from Microsoft project. And they were basically saying, well, we can quite easily use a container registry to store more than just containers. And at the time, I think they're primarily thinking of things like Helm charts.
Yeah, and that CNAB stuff that they're fond of.
Yeah. And actually, if you go and play with the Aura stuff right now, and you have an OCI registry such as Trow, you should find that you can't just upload artifacts to Trow or your container registry and get them download them again. It will depend on exactly which registry you use. And I haven't tested them all; just tested Trow.
I was trying to find the link to ORAS, but I'm getting Google returning me the
Deis Lab. Right? I guess if you were to search for ORAS and Deis, DEIS.
Oh yeah, I've got it on GitHub. Yeah.
Yeah, so that was quite an interesting project, and the OCI distribution project is quite interesting as well. It's so I mean, we really need a standard for our registries so that we have proper compatibility between everything, because all the clouds have their own registries, and I've never been quite clear what kind of code base they use, if they've based themselves with Docker distribution. I think in a lot of cases they haven't. They've just written their own bespoke implementations. So all the clouds have their own implementation of a registry, and then you've got multiple different registries like Docker distribution and Trow. So it's kind of important we get the specification right, so that on top of that you got multiple clients like CI/CD and Docker clients and so on. So it's kind of important that we get everything able to work together.
Yeah, definitely. And as we start to proliferate with more and more of these artifacts that we need to have in order to run clusters.
Yeah.
So if folks want to get involved with Trow, what's
Trow?
Trow? God, I've got confused when he just talked about it.
Yeah, maybe I made a mistake here, but I don't mind if people say it wrong, and I guess they're going. Yeah.
So if folks want to get involved with the project, where's a good place to start? The website?
Oh, definitely GitHub. Yeah, there are some if you want, it's written in Rust that I think you might come on to. But if you go and look at the issue tracker, there's some sort of getting started issues there. I mean, I'm really just looking for users and feedback. That's the main thing that I'm really interested in at the minute. So if you're using Trow, please send me a tweet or whatever, and let me know what you're doing with it. Yeah, but there's stuff in the issue tracker you can take a look at. There's also contributor guidelines you can, and always feel free to reach out to me on Twitter or whatever. But yeah, GitHub containers solution/Trow is the
right. So let's circle back then to Rust, and just touch on that a little bit. Why did you choose to write this in Rust?
Yeah, and that's a good question. I ask myself that sometimes.
Because it'd be much easier to get loads of contributors writing it in Go.
Right, and so I did start off looking at Go, and I got this weird line here. I have there it is. I have a battered copy of the Go programming language book, but I got like a few chapters in, and I got annoyed when I hit like a memory problem. And then I looked at Rust, and I have to say I much prefer Rust as a language, and I want to learn Rust. So those are the main reasons. But actually, perhaps less in the case of a container registry, but certainly for doing networking code and things like that, Rust is really good because there's no GC, so you don't get that. You're never going to get your sort of millisecond pause while it does cleanup and things like that. And so I don't regret doing it in Rust. It's the safety thing has been really useful as well. Once you get your code compiling, then it tends to work. Not always, of course. You can still write broken software, but yeah, there are a lot of advantages to using Rust. I definitely didn't want to use something sort of larger like a Java with a JVM, and so my choice really was Go or Rust, I guess. Yeah, I could talk a bit more about Rust. I have really enjoyed it, and I would recommend people look at it.
What's the kind of library ecosystem like around Rust these days? Is there
right? So I was just about to come on to it, and that has been like the biggest problem, especially when I started Trow. It was we're using Rocket at the minute, which is the web framework, and Rocket's really quite nice, but it's probably a bit too high level for what we do in Trow. And so I might need to change to something like Warp, which is one of the newer web frameworks. There's some really nice stuff. There was a post on Hacker News recently about the Rust TLS crate. And yeah, basically they've done a really good job of stuff like that. And networking and concurrency stuff in general are pretty good. But and the module system's really good. And if you go to crates.io, that's the site that you can find all the, the equivalent of npm or whatever, and you can look up all the different libraries. But it's not as mature as Go, and definitely nowhere near as mature as Java in terms of that.
Yeah, I mean, it's one of those things I keep thinking I should go and kick the tires on it. I mean, I'm slightly behind the times here in that I'm only just starting to get my head around Go. I'm like a dinosaur. Python's always been my go-to, but
so that is the problem with Rust. And one issue with getting people to help me is that Rust has a pretty large learning curve. And you have to understand the way it handles memory, because I mean, I've told you that there's no GC, but yet you don't have the same problems with C and C++, and that's true. But the way it's solved is by using something called a borrow checker. So Rust basically ensures that there's always an owner for any sort of resource or memory, if you like, and when that owner goes out of scope, the resource gets deleted. I think it's a garbage factor. It's not garbage factor. It happens at a specific time. And so when you first write in Rust, you'll end up fighting the borrow checker the whole time. And until you really understand how that works, it's a bit of a learning curve.
Because it starts killing off things that you've created.
Yeah, no, it doesn't kill things off. It'll just throw an error saying I can't figure this out. It'll say, you've used this, but you can't use this because it gets deleted here, sort of thing.
I'm with you.
So it won't let you have a reference to something that may have been deleted.
I mean, it's interesting, isn't it? These new kind of programming language ecosystems. I mean, Go is massively popular now, but I mean, I don't know whether we're necessarily producing computer science graduates, and especially in the UK, who have those skills. I mean, certainly when I was doing university work not that long ago, they weren't teaching Go on most university courses, and I don't suppose they're teaching Rust either.
Well, to be honest, I did have an intern that had just left uni working with me, and when I was first working on Trow, and he knew more Rust than me. And
it's interesting. Perhaps things have moved on then.
Well, no, he didn't get taught it at uni. He chose to do it as an elective or whatever, but he didn't get taught it. It was just, he was a geek, for the want of a better word, like us, and he was just interested in it. So I learned quite a lot about Rust from him. So that was great.
So you had an intern.
It was Hamish. I should give him a shout. It was Hamish Hutchins. So if he ever watches this,
he taught you everything you know about Rust.
I wouldn't quite go that far, but at the time he did, yeah.
Oh, that's cool. I guess we're kind of coming up to the hour here. I'm always amazed how fast time flies when you're having fun. So we should do our last final little section that we like to do on the show, which is just this picks section of things that you random stuff that you might have found interesting over the last couple of weeks. One I wanted to start with was the sourdough library, which is just completely random. Who would have known? So this is this place in Belgium where they're holding. I love sourdough, so I'm kind of a bit of a geek about this, although not making it myself. But so they're holding a library of these sourdoughs. Some of them can be 500 years old, right? These have been continuously kept alive and fed stuff. So it's very unique that this sourdough library exists.
What do you feed a sourdough?
Sorry?
What do you feed a sourdough?
Well, I don't know what you put in them. People keep them going and pass them from generation to generation now. I don't know what they're basically yeast kind of bacterial things, aren't they? So yeah, I don't know. But apparently this dude has to get they're all stored in like temperature controlled conditions, and then every few weeks they have to like get them out and feed them. Like they're living organisms, right? At the end of the day, super strange. But apparently you can visit if you're ever in Belgium and you're interested in sourdough. You can email this dude and he will show you around the sourdough museum.
Okay, great.
What have you seen this that's caught your interest?
Okay, I think we can start with a slightly serious one. So I saw a talk by this person, but he was tweeting recently. I mean, certainly following all the Black Lives Matter stuff, which was Anman tweeted about what basically white engineers like us can do. And he has a talk called Lending Privilege. And I'm sure we'll link it in the notes, but if you go and watch his talk, it's basically, one of the examples he gives is back in the 1960s Star Trek, there was Leonard Nimoy and what was it? Nichelle, the woman that played Uhuru, Nichelle.
Yeah. That was a massive thing for racial relations, wasn't it? Wasn't it the first
interracial kiss? Is that what you're going to say?
Interracial kiss that had been on television. Yeah,
that wasn't Nichelle. That was Kirk and some random alien, wasn't it?
But I think the first, kind of.
Right. So to be fair, Star Trek's got a really good history. Yeah. One thing that happened was Leonard Nimoy found out that Nichelle wasn't being paid the same.
Oh yeah, I've heard this story as well. Yeah, go on.
And it was him that pushed for her, to be paid the same.
Yeah.
And Anman was just given that as an example of how white people can help stand up for people, because she wasn't able to make the argument herself, but he could, and he did. So he used his privilege, if you like, in a powerful way. And to be fair, he might have been a leading actor, but it wasn't at a time when Star Trek, it was before the films. So he wasn't the big star he is now, or was now. And it's a great talk to go and look at, and I think at these times and see how we can potentially help it. And to be fair, it's something that I feel I have at times failed at. I've gone and looked at. I run the Docker meetup in Edinburgh, and I feel we probably should have done a lot better about helping voices and faces that you don't always see in tech be more represented. So that's something that I'll vow to try and do better in the future. But
yeah, great. So I've just stuck his website up there, which has got the talk that you've talked about there, Lyndon.
Yeah, it's years ago I saw it's a conference in London. I can't remember. QCon. It was QCon. But it's a great talk, so I do recommend watching it.
Yeah, great. As with most things, I'll try and go back through the show next week and add the links to the YouTube description as well, so folks can look at it from there.
Cool. Do we have time to do my no paint?
Do your last one then.
Cool. So you might have seen it. Some of you probably saw this, but there's a site, nopaint.art, and if you go on it, there's only two buttons, like paint or no. And you could create your own artistic creations. But yeah, all you can do is click paint or no, and you just click it. It's hard to describe, but can you do a demo?
Yeah, I'm just trying to work out why I can't do a demo. Wait a sec.
Oh well.
Why is that?
But basically,
reload the page. Hang on a sec. I'll reload the page.
You start it, and it'll start drawing things. And if you like what you see, you click paint, and it keeps it, and that'll start drawing something new. If you like it, you click paint. If you don't, you click no, and it'll try. And you keep going until you've built up something you like. But there's no rules. You can't do spray painting or anything like that. And if you'd like to see my attempt, you can go onto Twitter.
There we go.
Yeah, well, that's not bad. Yeah, well done.
Oh, paint. Yeah,
I'm really impressed with this. Well done. Yeah, so you get the idea now.
It's just the bizarre things that people come up with. Who'd have thought that would be entertaining?
I'm actually quite proud of what I made.
Okay, well, we've pretty much come to the end of the show. Thank you for everyone who has listened on the stream. Please do like and subscribe below somewhere. You can follow us on Twitter at We Jump Sharks, and you can find all of the previous episodes of this podcast on the YouTube channel. There's some super interesting folks on there too. So if this is your first visit, please do check out some of that other content. We'll be announcing the next set of guests very soon. So keep an eye on Twitter and YouTube. Thank you again, Adrian, for joining me today. It's been super interesting, and I enjoyed chatting. Thank you to our sponsor, D2IQ, and we'll see you all next time.